Welcome to my channel. In this session, we will discuss arrangements or permutations first part. This is the fourth in a series of videos that we are making on permutations and combinations topic. Arrangements or permutations. Let's discuss this with an example. If there are 5%, if they are to be seated in a row, what is the different number of arrangements or permutations? Let's see. If I take the first position, leftmost position, how many options we have? Any of these 5% can be seated here. We have 5 options for this place. To the next place, since one person is already sitting here, there are 4 other persons. We have 4 options. Any of the 4 guys can sit here. To the third one, since 2 persons already seated in the first 2 places, still 3 persons are left over. Any of the 3 persons can be seated here. We have 3 ways or 3 options. To the fourth one, since 3 persons already seated, we have 2 persons left over. Any of those 2 persons can be seated. So we have 2 options. And coming to the last position, there is only 1 person left over. That person will sit here. There is only 1 option. So the total number of options means, from the earlier sessions, the multiplication principle, the total number of options we have is 5 into 4 into 3 into 2 into 1. It is 5 factorial, or we can say it is 120. 5 4 20, 60, 120. So students, we can say that if 5 persons are there, they can be arranged in 5 factorial ways. So if there are n items, number of ways of arranging n items in a row is n factorial. Number of ways of arranging 5 persons in a row is 5 factorial. Right? Okay, let's take up one more concept. Now students, I have 5 persons, but if there are only 3 positions, 3 chairs to be occupied, how many ways we can arrange people in these 3 chairs means, if you look at the first chair, there are 5 persons. Any of the 5 persons can be arranged here. So we have 5 options. To the second chair, since one person is already sitting, the remaining 4 people, any of the 4 persons can be seated here. 4 options. Since 2 persons gone, for the remaining chair, there are 3 persons left over. Any of the 3 persons can be seated. So the total number of options is m into n into p. The multiplication principle or fundamental principle we have discussed in the first session. 5 into 4 into 3, that is 60 options. This is one way of explaining that. Another way of explaining this is, this has got actually 2 stages. First, out of 5 persons, only 3 persons are going to be seated. It means you have to select 3 persons out of 5 persons. How many ways I can select 3 persons out of 5 means, if you see from the earlier sessions on selections and combinations, we say 5C 3 ways. So out of 5 persons, 3 persons can be selected first in 5C 3 ways. Once you select those 3 persons, those 3 persons can be seated in these 3 positions in how many ways means, as I've just said, 3 persons in 3 positions can be seated in 3 factorial ways. So the total number of options is 5C3 into 3 factorial. And what is NCR formula? You know, NCR formula is n factorial by n minus r factorial into r factorial. So 5C3 equals to 5 factorial by 5 minus 3 factorial into 3 factorial. This is 5C3 into 3 factorial. If I do, you can see 3 factorial gets cancelled. It will be 5 factorial by 5 minus 3 factorial. So it is 5 factorial by 2 factorial. 5 factorial is 120 by 2 factorial 2. My answer is 60. Right? So now here we are not arranging all 5 people. We are arranging only 3 persons. So the number of ways of arranging r items out of n items will be, arranging r items out of n items will be NPR. As I said, this has got 2 stages. First, we have to select r people out of, like we are selecting 3 people out of 5. We have to arrange r items out of n items means, first, then I have to select them in NCR ways, like I selected 5C3 ways. Then those R people who are selected, or R items that have been selected, can be arranged in R factorial ways. It is NCR into R factorial. If you recall here, NCR equals to n factorial by n minus R factorial into R factorial. into r factorial. If I do it like 3 factorial is getting cancelled, r factorial gets cancelled. That's why we say, students, npr equals to, you can see, n factorial by n minus r factorial. So arranging 3 persons out of 5 persons will be 5p3. We can directly say, instead of writing all these 5p3, which is 5 factorial by 5 minus 3 factorial, which is 5 factorial by 2 factorial, which is 120 by 2, 60. Right? Okay. Next, what if 5 persons have to be arranged in a circular table? If I have to arrange them around a table in a circular arrangement, how many ways we can arrange these 5 persons? Means, students, here there is no end. Who is sitting leftmost? If it is a row, who is sitting on the left position, who is sitting on the right position will make difference. Since it is a circle, first you take one person and make him sit anywhere. Suppose if one person is sitting here, so who will sit here means, how many options I have? If one person is sitting, to someone to sit right of him, there are 4 options. Any of the remaining 4 people can be seated. And suppose if one more person has to be if one person is sitting here, how many options are there to someone to sit here means, so there are 2 persons already gone, 3 ways. For one more person here, it is 2 ways, because only 2 persons are left, and here one way. So it is 4 into 3 into 2 into 1, it is 4 factorial ways. In other words, because there are 5 persons, one person you have to fix first position and then arrange them. We say it is 5 minus 1 factorial, or in other words, we can say it is 4 factorial, which is 24. So what we can conclude out of this is, number of ways of arranging n items around a circular table is n minus 1 factorial. Right? Students, here when you are arranging them, who is sitting here, who is sitting here makes difference. That means who is sitting right of him or left of him matters, or clockwise or anti-clockwise matters. However, if you look at a garland which is a hanging item, so whether it is clockwise or anti-clockwise doesn't matter, because it looks from, if suppose something is hanging, from which side you are looking matters. So that's why the clockwise and anti-clockwise is not important. So hence we say, number of ways of arranging n flowers in a garland is n minus 1 factorial by 2. The common mistake we do is, we think that garland is like a circular arrangement. We may say n minus 1 factorial, but please remember it is a hanging item. So it is n minus 1 factorial by 2. Right? So these are few important points on permutations and arrangements. In the next session, we will discuss a few more concepts and few more examples. We'll apply them and solve few questions. Students, please do subscribe to my channel so that you can see all the topics of quant which is required for any entrance and competitive examination. Thank you.